Welcome back, everyone, as we head into the final few hours of Technology, AI, and Cyber Live. But stay tuned because joining us next is Lisa O'Connor. Now, Lisa is the global leader of security research and development at Accenture, leading two labs in Washington and in Israel. Through her work, Lisa protects the global 2,000 companies, critical infrastructures, and advances the industry with a focus on cyber innovation. Her role is to ideate, develop, and co-innovate with Accenture's clients. With more than 31 years of experience in information security and more than 17 years of that in both commercial and federal financial services organizations, Lisa brings a depth of business knowledge to Accenture's customers. Now, Lisa has been with Accenture for around 8 years now, but in previous roles, she spent 5 years at Fannie Mae, 7 years leading national security consulting practices at Predictive Systems, 4 years at PwC, and 9 years at the National Security Agency, including assignments to the White House Communications Agency. So great to have Lisa, and welcome to the show.
Thank you. I'm very happy to be here.
That's great, Lisa. So look, I know you've got lots to share with us today, so I'll hand over to you for your presentation.
Great, thank you. So I am very excited to be here today. This is a wonderful topic, and I'm thrilled that we have technologists, we have AI specialists, and we have cybersecurity people here. And I think my hope is that everybody gets something out of this presentation, because we're going to talk about some of the challenges with AI. We're going to talk about the business and some of the leadership challenges that we need to make sure we address along the way. So I'll tell you a little bit about my role at Accenture, because it's kind of exciting. It's the best job ever. And I get to go deep with a team of researchers to really chart out what the future is. And in Accenture Labs, we try to stay 3 to 5 years ahead. So the things I'm talking to you about today are things that we've been researching for the better part of 4 years, and developing the techniques and the methods and understanding how AI behaves, machine learning, deep learning, and where its weaknesses are, very candidly, because we think about AI as an enabling technology, and we also want to know how to protect it. And so we'll get into all of that today, and I'm really excited about the opportunity. So let's get started. So AI is increasingly pervasive. I don't think there's anyone that this is going to be a spoiler alert for, that AI is in many things that we do, many services, many enabling features for citizens and businesses that we use and we enjoy. But we have increased complexity in this. And as we start to use it more and we build more in AI, it really decreases what the interpretability is of the AI. And this becomes harder and harder for humans to really get their heads around and sort of understand what's making the decisions, what's in the black box. And what we're seeing is that adversarial AI is here. And that's really these attacks against AI itself. And when I say attacks, I'm talking about the model, the data, and that could be the training data, or that could be the data that's coming into it as it sits out in production. How those models can be changed, how the outputs can change, how they can misbehave, or adversaries can take advantage of them. And one of the challenges that we have is that there is a lack of knowledge and skilled people that really understand how to manage the security and privacy of these models and the data around them throughout the life cycle of AI. So that's a big industry challenge we have, and through this conference, hopefully we're really focusing on that and getting our acumen up and our business sensibility about it up. But the bottom line here is that the algorithms are the new front line for cybersecurity teams. AI changes the attack surface. And so it's not just new targets that we have something else out there in the cloud to go kick the tires on or knock on the door. We have new attack methods, and that's really using AI to attack AI. So we have models attacking models. And what we've seen is that the best way to kind of characterize this is think of an attack over time. And so for my cybersecurity folks, you'll understand this in that it's a slow and low. It's not something that is a big bang event. It is typically slow and low that the poisoning, the evasion, the inference, those things are happening. And what happens is the attackers are making very minute changes to the models, minute changes over time. And those are hard to detect. They're hard for people to detect. And eventually, with enough small changes, you actually start to stack things up and you get different behavior out of that model. And then the model may become unstable. It may make predictions that that based on look like normal inputs, but something very different is happening in the output of that model. And the attackers know this. And with those small modifications, it's getting them the adversarial outcomes that they want. And again, kind of think about this as gaming the system, whether it's defeating content filters, all the way to, shutting down systems or catastrophic failures. And so that's kind of the scope of what we're dealing with. And machine learning, as we see, and specifically deep learning, these are very, very hard areas in the sense of being able to see what's happening and have that explainability. Most of them, it feels like it's a little bit of a black box. And there are many different kinds of learning techniques. There's supervised, unsupervised learning, other ways of kind of thinking about what type of AI may be appropriate for the business challenge that you're trying to solve. But the bottom line is the high complexity of machine learning and even higher complexity of deep learning really make this susceptible to an adversarial attack. And machine learning, if we think about that, that's whether it's a classification model or training, we train on a set of things and we decide an outcome. The quality of the data going in is very important. The quality of the labeling of the data so that the model is trained properly is important. Deep learning is a little bit different. It's a little bit more hands off, if you will, in the sense of it takes great amounts of data to train it. But what it's doing is it's iterating. It's iterating on the nodes and really making sure that it's going through many transformations before it gives you an output. That way, it's teaching itself along the way of what the right output is. Those are even harder to really understand everything that's happening under the hood. So I want to talk just a little bit about the machine learning ecosystem, just so we're all on the same page. And we have, we'll call them participants or members. And these are groups that may have data, may have things that they want to organize or get insights out of, that can share that data or provide that data to a model developer or to a service, and again get the insights, train the model with that original data. And then you have in the center, you could have your developer. This could be in-house or it could be a third party, but there's an ML expert in there working sort of the boundaries and understanding how to get the right outcomes out of the data, and that what's going to be achieved, right? And making sure that things are labeled well and that the outcomes are within the tolerance, and sort of making sure that we're not overcorrecting or undercorrecting in the model, but that the weights and the boundaries are right. And then on the far side, we have the users. And so once the model is complete and put into production, you could have many different users, if you will, using the model, leveraging it for insights. And so those are, once the model is in production, those users are going to get their insights out of the model. And so when we think about the security and privacy attacks on AI, we got to think about sort of that whole ecosystem. And there's even more we have to think about. So we think about the players, which we just talked about, the participants, system servers, developers, customers, or users. We also have to think about the type of data. What kind of data are we acting on? Because that also will govern some of the nature of the attacks, the adversarial attacks that could happen. Is it image data? Is it video? Is it audio? Is it tabular? And I think, we're all pretty familiar with some of the deep fakes on videos and audios and other things. But if you look at the business world, a phenomenal amount of the data is tabular. And so understanding what models work well and what attacks may work well on tabular data. And then we have thinking about the attack phase. So attacks just don't happen in production. We have to think of that whole pipeline, because from the time you actually curate the training data set and you decide what comes into the model, you already need a protected environment, and you need to understand what your standards are for that data, where it came from, veracity of it, usability of it, a whole bunch of things that you want to verify before you train your model on that data. And then there's the inference, which is really the in production, where the model is giving you its output. That is another way to attack once the model is in production. And we have many methods of attacks, and you all may be familiar with the MITRE adversarial ML attack framework. These are some of them that are listed here: model biasing, poisoning, backdoors, model extraction, and most of those are in the training phase. And then you could have participant data leakage, membership inference, model extraction, and evasion, and those all happen sort of in the inference phase. But one other thing we need to think about is, where's the AI located? And so, is it within our networks? Is it on a private cloud? Is it AI as a service? We're using, models as a service. Is it a dedicated party? Is it multi-party? Is it on the edge? Is it somewhere sitting on a smart edge that now we're going to do our calculation in a different area, and our AI is sort of exposed differently? Where you put it also would drive what kind of protections and defensive techniques you need around it. And so as I mentioned, we're going to just do a quick run through of some of the attacks. And this is really to kind of provoke some of the thinking, or seeing how others, adversaries, may take advantage of models, and really get our acumen up with what sort of the state of play is. So originally we started with, computer vision and attacks, recognizing things. And many of you are familiar with the stop sign, having our automated driving identify a stop sign as a yield sign, or not even identify the stop sign, or misinterpret a person. And for those of you that remember adversarial patch, where you had to hold up this big, huge artifact, that then it was a visual artifact that when it came in front of the camera, the person can disappear. It just didn't recognize it. Those attacks have gotten much more sophisticated, much more subtle. You don't have to hold a big sign. There was OCR, optical character recognition, where banks that are taking input, through checks and pictures of checks and clearing it, interpreting the ML, misreading the information, so that from an application perspective, it looks fine. From a human eyes, it looks fine, but what happens in the background is very different. And that deposit of, 10 euros just became 10,000. And natural language processing. And this is, again, we've seen lots of examples of this, where it could be misclassifications. And these are things that either they're close in meaning or close in structure, that it misclassifies them and brings them into the wrong characterization. So we'll talk quickly about one, and this was someone taking advantage of a model, right? It was the flash crash. And again, predicted behavior. The adversary studied the model, studied what the behavior was, and really probably wrote just a very simple script to take advantage of it by posting, requests to cells that exceeded what the model expected. And because the model was set up in a way not to expect these sort of out of band things, these were not characteristic inputs to be bidding very large, way above the maximum for selling. It definitely drove the model into a spiral, and that spiral ended where the adversary then, once the price dropped significantly, because again it sort of started a stampede of people being concerned, that's when the adversary bought in, and it came right back up again. And so that's somebody who's watched, an adversary who has watched how a model behaved to specifically take advantage of it for personal gain. And we'll move to one, and here's a good one for security folks, because in cyber defense, we have to act at the speed of the adversary, and there's so much data coming at you. It requires that we actually also use AI and start to understand 0 days. And this is especially true of antivirus. This is true of spam, any of those 0-day detection things. We're trying to anticipate what that next thing is. And here's a case where some researchers were looking at what Silence was doing in their antivirus, they've noticed a bias. They noticed a positive bias in a specific piece of software, and it was gaming software. So they studied the gaming software and they figured out if they could append a couple strings from the executable to other known bad files that Silence would normally pick up. They could game the system, they could trick Silence filters into the ML into accepting the bad files. And so again, another one where if your model is showing a bias somewhere, or showing something that may not be consistent, or it's a tell, there are ways to take advantage of it. And this is a case. And it's, again, these are not limited to Silence. Silence was used as an example in this case, but it gives us good pause in knowing how we're setting up and how we're training, and are there any biases or anything else that someone could take advantage of in a model. And another interesting example was the Google autocompletes. And the thing about natural language processing is that it studies natural language. And when you're studying what people are searching for, emails or other things, it is coming up with patterns. It is coming up with associations, and it will happily present those back. And in this case, the model was trained, but I don't think they realized what might be coming back and sort of the autofill. Because at that time there wasn't sort of the rigor in looking at what would come back, and some of that information may have been sensitive. And in the case of this example, a Japanese citizen was made a claim that again, he was harmed by this because different things came up associating him with criminal activity. And ironically, maybe go search yourself, because you might be surprised at what strange associations may come up, right or wrong. But in any case, it is a more frequent one because it is language, and this is a very special area of machine learning that we need to be sensitive to. And another interesting one, and I say this because this is what happens when you build something really, really cool and sophisticated, how people could misuse it, right? And again, in trying to manage all sorts of bad criminal activities, and especially with minors when it comes to trafficking or other things, there's a lot that happens in images. And so image processing, understanding who has these images, where they're going, is important to law enforcement. So the adversaries, in this case bad actors that are perpetrating this, figured out how to exploit the normal MD5 hashes to evade being detected as an illegal image. So they came up with a wonderful neural perceptive hashing, which instead of taking the regular MD5 hash, actually creates something very sophisticated, that it builds literally its own neural hash of the picture. And little changes to the picture or little modifications do not change the association between one image and the other, and it can make the connection of where the image went. Anyways, wonderful, great application of technology. The challenge is you can also use this in the wrong way, in the sense of you can create this and actually propagate calling bad pictures in the system that are actually benign pictures. And so if you wanted to target somebody, or you wanted someone to show up on the police's list, law enforcement, for these things, you would just tag a bunch of their pictures with this, and sure enough, they would show up as probably needing to explain the pictures, or at least share. So again, it's how bad actors, can use some of these things for ill gain. But back to business. What really spooks me is that 79% of executives reported that their organizations are adopting these technologies faster than they can address related security issues. And so that's a concern. So security organizations, business executives are adopting these things faster than they can get the protective defenses in there. And we've seen that on our research last year that we did for the security technology vision, where we looked at innovation and how companies were innovating, and AI was a big focus of this research. So with that, there's a lot of things we need to do. And, again, we've talked about the sort of the package of what you want to push forward to make sure that your model is resilient to attacks, and that the private data that you used either in training or that you're using in the inference stays private. And these are big things. So you have to ask many questions, again, an appropriateness of the model. And you probably even need to ask questions in the beginning of, is an AI or ML model the right thing to use? And there are so many great insights that we can get from these models, but making sure they're secure and trustworthy is really important. So there are a number of things that you can go through and sort of think about that risk assessment framework to make sure you're not vulnerable to model extraction, model manipulation, compromise, memorization, inference, data poisoning, and API attacks. And these are all areas that my research teams have done some amazing works and proofs in, which is really exciting, which help us think about what are the boundary conditions, what are the things you would want to build into those models or into the data to make it more resilient. And so some of the things we talked about, model extraction, and it's what's amazing is most organizations do not even know this is possible. Like, again, having your model out there, it is and especially if it's exposed externally, if you don't have the right threshold set for how many times an entity can knock on the door of your model, you sort of have that brute force attack going on, and that brute force attack results in cloning, right? And we call that model extraction, literally building what is a comparable model with nothing but the outputs, because you know what the answers are with enough of your inputs, and you can correlate inputs to outputs and create your own. So understanding if that's important to your model to protect it that way, where your model's sitting, is it internal, external, and making sure that you have the right guardrails up on it. And data poisoning is really important too, especially as we think about where the data comes from. So data poisoning is making sure that your data is appropriately sanitized. And this is where the heavy data sciences come in, is understanding the data in your set, looking at it, and literally seeing if it jumps out to you that these sets do not mathematically make sense anymore. The way the data is presented doesn't make sense. And there are ways of detecting this mathematically if the data has been poisoned, and there are ways of cleaning it, which we've demonstrated on a set of satellite data, which is pretty exciting. Membership inference, again, this is where you can kick the tires on a model and find out if somebody was part of the training data set, even though it's supposed to be anonymous. And these are things that you need to make sure that, especially in fields like healthcare, where you're dealing with customer data, that made up sort of the basis for the study, you want to make sure that their privacy is protected and their security is protected, their identity. So that also becomes very important. And there's a whole set of other things that we're going to talk about quickly about encryption and how do we sort of move and protect and do things like federated learning and federated split learning, where my data is protected the whole time. And the other participants may have their data protected the whole time, yet we can do federated learning and federated split learning. And those are really exciting propositions where now we can think very differently on how we use our data to get insights and who we want to share with or not, because we can do it securely where no one sees my data. And those are really exciting opportunities which kind of open up the door on what businesses can do. And the biggest thing is to plan the transformation journey. And this is from preparation and thinking about why the model, why this model, how you're going to use it, do you understand the risks, to that transformation, the secure design, all the way through to collecting data, training, going through the whole life cycle of it, and managing it once it's out. And that's the continued evaluation that we have with these models. And what I'll also add, and again, I'm sure this resonates with the audience, is there are huge value drivers for security And again, not just sort of the reputational, though those are very visceral. You don't want anything going bad with the models that you put out and hurting your customers or having the wrong judgments or decisions made because of them. But it really, you want to reduce that risk and gain competitive advantage, because the insights that you can get by using AI and using machine learning and deep learning are amazing, right? You get great insights where you may not know every input, every output. You get that insight to make the next best decision. And it's a big transformation. You're disrupting the processes. So this isn't just quickly lift and put a model in. You're transforming how you can do business and how you do business forward. And those are big changes, which, again, are strategic advantages if you do them well. And again, I think all of us want to increase the credibility and reliability and trust in AI, ML, deep learning, such that we are protecting ourselves. We are making sure that we're protecting the data and the data owners on those insights. And I think the assurance, this is going to be really important to our future, because we want to be doing AI in a way that the public can trust it, that our customers can trust it, and it's explainable. And those are very important things. And many of us are operating in regulatory environments where we need to make sure that there is traceability, explainability, and that we understand the outcomes of the AI and the impact that it has. And if we get to business value drivers for privacy, and these are the exciting part here, I think, is in what it can do. And I talked about the homomorphic encryption, federated learning, and federated split learning. There is so much that can happen if we're able to share safely. And by doing that, by share using machine learning models across organizations. And you could just picture this in healthcare, where it might be very sensitive information, but there's a way of doing it where you didn't have to disclose anything to the model, and it can operate on it in that encrypted manner. That has huge impacts for how we think about healthcare in the future, or how we think about decision making in the future, or the collective power of ecosystems. And that's where I get excited about this stuff. And also thinking about sort of data for good, where it may be, something that transforms the human experience or the quality of life, or what we can do if we team together, where historically that might have been harder to do. And those techniques like federated learning and split learning and homomorphic encryption allow us to do that safely. All right.
Okay, Lisa, thank you so much. There's a lot of information to take in there. I'm sure our attendees today have 1,000,001 questions for you. Unfortunately, we're running a little bit short of time, but I am going to squeeze in one question for you, Lisa. And obviously, you've been working in this area for a long time, and nobody probably knows it better than you. What excites you most about the research that your team is doing on, relating to trustworthy AI? And we've only got about 1 minute left, so do please try and keep it brief.
Quick. Yeah. So I am excited about the research, and I think it really hangs on kind of the last thing I was talking about, is if we get this right and we are able to think about AI across ecosystems, across industries, and what it could do just in security alone. If we could share sensitive data to talk about what's happening within our companies, and do it in a way that the machine learning gets the benefit out of it and we all get the insights out of it, without sharing what might potentially be very sensitive data about vulnerabilities or other things that are happening. That has huge power to uplift all of us, and that gets me excited.
Okay, great. We'll have to leave it there, I'm afraid. But if anybody has any questions for Lisa, obviously you can network with Lisa directly through the event app, and I'm sure she'll be more than happy to field any questions you may have. But for now, Lisa, thank you so much for your time.
Thank you.
Okay, stay tuned, everyone. The next session's coming right up.